Okay. So, let us start. So, this week we will discuss about that microphone and loudspeaker design. So, before we go for that microphone and loudspeaker design and specification, let us start what is transduction, because what is required when I say the microphone and loudspeaker, it is nothing but a acoustical transducer. So, first we start from the transduction and then go for the acoustical transducer. So, transduction, the meaning of the transduction is that converting of one form of energy to other form of energy, maybe heat to mechanical rotation is one kind of transduction. Similarly, acoustical transduction means converting acoustics energy to electrical energy and from electrical energy to acoustical energy. So, if we see in real life, when I speak or when a sound is generated or say that a sound source is produce a sound, it is nothing but an acoustics wave. Now, if you see that if you want to process that acoustics wave, suppose I want to amplify it, I want to filter it or I want to do some sort of modification on it, then what is required? Because all of things will be done on a electrical circuits. So, that means I have to convert that acoustical energy to electrical energy and or rather I can say I have to convert that acoustical signal, if I say the acoustical signal to equivalent electrical signal and modify whatever I want on that signal modification, maybe equalization, maybe amplification, whatever I want, and then convert back to acoustical signal. Suppose requirement, let's say that amplifier, you see that audio amplifier you have seen. Why it is audio amplifier? Because there is nothing audio, that is everything is electrical signal. Okay. So, in audio amplifier, if I say I want to amplify an acoustics wave, I say in a source, this is an acoustic source, produce an acoustic signal, let us say human being produce a speech. Then I have to convert that speech or I have to amplify that acoustic signal to spread it in this side. So, what I will do, I will connect a loudspeaker to an amplifier, acoustical amplifier, and I connect a microphone to an acoustical amplifier. So, this is input and this is output. This is the amplifier is electrical amplifier. So, what I do, I convert acoustical signal to electrical signal, then I modify that electrical signal by a gain less G. So, Eg, then Eg will be delivered to a loudspeaker where it will convert from electrical signal to acoustical signal. So, I require a transduction in real life application from acoustical signal to electrical signal, similarly electrical signal to acoustical signal. Similarly, if you see human being, if you see the psychoacoustics transduction, let us these slides, this is the acoustics to psychoacoustics transduction. What is happening if you see, there is a loudspeaker which produces a acoustical and mechanical energy or acoustical energy, and that acoustical propagation will done here mechanical to, so loudspeaker is a mechanical to acoustical and then acoustical propagation has done, then acoustical to mechanical, because this acoustical signal goes to the membrane will vibrate. So, acoustical to mechanical, then mechanical signal goes to the cochlea and cochlea convert in nervous psychology electrical signal or nerve signal, and that create an perception. So, that is electrical to psychological. Okay. So, similarly, in case of amplifier, I required an electrical signal. So, what I do, acoustical to electrical, then electrical have put some operation and then again electrical to acoustical. Okay. So, how do you do it? How do you do it? We want to transform that, let us electrical to acoustical and acoustical to electrical. Now, if you see, there is a called electrodynamic transducer. So, the device which transduce acoustical to electrical is called transducer. So, it may be a microphone or it may be a loudspeaker. So, it is nothing but a acoustical transducer. So, let us one form of the acoustical transducer is called electrodynamic transducer. What I said here, the force, mechanical force is nothing but a B into L into I, you know that, B into L into I, L in the length of the wire, I is the current, B is the magnetic field strength, then the applied force will be B into this cross product of B into L into I. Okay. Then similarly, if I in a magnetic field, if something is rotate, then what will be happen? There will be electrical current will be produced. So, I can say V is equal to B into L into U. U is the mechanical velocity or moving velocity. L is the length of the wire. B is the magnetic field strength. So, L cross L into U is produce a mechanical voltage. So, by a electrodynamic principle, I can convert. So, this is the acoustic velocity. I can convert that mechanical velocity to electrical voltage or mechanical force to electrical current. Electrical current to mechanical force. Okay. So, in a loudspeaker, I can say in case as a microphone, I want mechanical force must be converted to electrical signal. So, I use this equation. If I want in loudspeaker, there will be electrical signal, I will be flow and I have to create a which by which the diaphragm will vibrate. The mechanical, the vibration is nothing but a mechanical oscillation. So, this force create a mechanical oscillation which produce the sound. Similarly, another kind of example is that electrostatic transducer, where I use capacitance, variable capacitance as a transducer. What it means? Suppose I have a two plate of capacitance and gap between the two plate is x0, okay, and dielectric constant is epsilon 0. Okay. Then force acting between the two plate is nothing but a dielectric constant multiply the surface area of the plate multiply by the voltage applied voltage square divided by 2x square. X is the distance between the plate. So, if the x is the distance between the plate and if the V voltage applied across the plate, let us say I apply a V voltage across the plate, voltage V applied, then the mechanical force which is acting between the two plates is nothing but a epsilon dielectric constant multiplied by the surface area of the plate into voltage square divided by 2x square. Okay. So, this create electrical energy converted to the mechanical energy. Similarly, if I apply a force in one of the plate, so distance will be changed and the voltage will be induced. Then I can say the mechanical force converted to equivalent electrical voltage. So, these two kind of transduction I have discussed. Let us discuss about the theory of transduction first and then we go for the practical application. So, let us what is theory? So, what it is said that I require a transduction. So, this black box is my transducer. This is a black box is my transducer. I have a two-port electrical network in here this side. So, this is electrical side. I can apply a voltage V here, a current can flow I here, and this is called mechanical side. So, again there is a mechanical force on here and the particle velocity will be U will be acting on here mechanical side. So, this is a transducer that has an electrical side and has a mechanical side. So, electrical side V voltage applied, I current induced, and here mechanical side F force is applied, U is the particle velocity. Okay. Then what will happen? Let us electrical impedance Z has two conditions, either this F equal to 0 or either U equal to 0. So, F Z E B, let us write E B, it is nothing but a V by I when E B blocked electrical impedance, when U is equal to 0. Why? Because this is called block electrical impedance. Suppose I have a mechanical transducer, and if I apply a electrical voltage, the diaphragm of the transducer will vibrate. Now, if I block that vibration, I say there is no motion of the mechanical force. So, there is no motion of the diaphragm. So, that means U is equal to 0. Then the electrical impedance will be ZEB, electrical impedance when the mechanical side is blocked, means no motion is allowed. Then there will be a ZEF when the motion is allowed, free motion, there is no mechanical force resist it to stop the motion. So, it is a free in motion. So, that means V by I when F equal to 0. So, it is called mechanical electrical impedance. ZE is the electrical impedance when it is mechanical side is free, means there is nothing acting on the diaphragm, nobody stop the diaphragm is vibrating. So, it is free from applied force, this force is not there. So, F is equal to 0. Similarly, in mechanical side I can say ZMS, short circuit mechanical impedance, is nothing but a force by particle velocity when short circuit. If it is short circuit, then it is nothing but a voltage is equal to 0. Then ZMO, open circuit mechanical impedance, it is F by U when I is equal to 0. Short circuit, if I make it short circuit, then the voltage acting on these two plates will be 0, two lines will be 0. So, the voltage is 0 means short circuit mechanical impedance, open circuit mechanical impedance. So, when open circuit means there is no current is flowing, so I equal to 0. Short circuit means current is flowing, but voltage equal to 0. So, short circuit mechanical impedance, open circuit mechanical impedance. This terminology will be used later on. So, I think this is a clear understanding is done. Now, let us, if it is that, then what is the equation? Let us start that, derive the equation. What is the equation? If I say I applied a V voltage when U is equal to 0, let us say V electrical voltage is a function of current and U is equal to 0. So, there is no mechanical velocity. So, only voltage is there with a U is 0. Then it is nothing but a U is 0 means ZEB. So, it is nothing but a ZEB impedance multiplied by the current, I. Now, if I say no, U is not equal to 0, let us U is varying linearly with relationship with V, then I can say V when I and U both are there is nothing but a ZEB into I plus let us, there is a coefficient called TEM, electrical to mechanical coefficient into U. So, U is not there. So, some component of the U contribute to the mechanical electrical voltage. So, I said that U is there and this is called electrical to mechanical coupling coefficient. So, coupling coefficient electrical to mechanical is TEM, coupling coefficient, and U is not 0. So, it is nothing but a VIU is nothing but a ZEB into I plus TEM into U. Similarly, if I say force, Similarly, I can derive the force. So, if I say force is only function of I is 0 and u, then it is nothing but a I is 0. So, it is nothing but a ZMO into u, impedance into particle velocity. Now, if I say it is not I equal to 0, so f is a function of electrical current and mechanical velocity, then it is nothing but a ZMO into u plus TME, mechanical to electrical coupling, and then I. Okay, you understand? So, I have a V equation and I have a force equation. Okay, and TEM and TM are the transduction coefficient. So, those are the coupling or transduction coefficient. Okay, transduction coefficient. Okay, now if they are the transduction coefficient, this is the equation number 1 and this is the equation number 2. Then, if V equal to 0, then in equation number what will happen? ZEB into I is equal to minus TEM into U. If I put that ZEB into I, so I is nothing but a minus TEM into U by ZEB. I put that I value in F equation, then what will happen? Let us I write F equal to ZMO into U plus TME into TEM into U divided by ZEB, or minus, this will be minus, there is a minus sign, into ZEB. So, if I take U outside, so it is nothing but a ZMO minus TME TEM divided by ZEB. Okay, let us I write that Kc square is nothing but a TEM TME divided by ZEB into ZMO. Okay. So, I can write F by U is equal to, what is F by U? F by U is equal to, I can write 1 minus Kc square into ZMO. This Kc square is nothing but TME ZEB minus ZMO. So, I can write 1 minus Kc square, ZMO will be multiplied here. So, ZMO will be common, 1 minus Kc square into this. What is F by U? Is nothing but a ZMS. So, ZMS is nothing but a 1 minus Kc square into ZMO. So, this is the relation between short circuit mechanical impedance to open circuit mechanical impedance. Similarly, I can derive the relation between ZEB and ZEB. Similarly, ZEF will be 1 minus Kc square into ZEB. Blocked electrical impedance and free electrical impedance, and Kc is called coupling coefficient. So, Kc square is nothing but a TEM TME divided by ZEB into ZMO. Okay. So, I can write. So, this is the relationship between the ZMS, ZMO, relation ZEF into ZEB. So, this relation I have discussed, I just said. Okay. Now, there will be two conditions possible in this equation. Those two conditions is possible, either TEM may be equal to TME, electrical to mechanical and mechanical to electrical, those transduction coefficient may be equal. If it is equal to T, then we call reciprocal transduction. Then we call reciprocal transduction. So, if it is reciprocal transduction, then what will happen? Let us this transduction is reciprocal transduction. In that case, TEM equal to TME is equal to T, same. Mechanical side to electrical side to mechanical side, both are same. In that case, so V will be JdV into I plus T into U, and F will be ZMO into U plus T into I. T into I. Now, Kc square is nothing but a TEME divided by JdV into ZMO. So, it is nothing but a T square by JdV into ZMO. Okay. I replace this T by a transduction factor phi, where phi is equal to T by JdV. Phi is equal to T by JdV. So, I can write this equation, phi is equal to, I take T by JdV. Then this equation I can write V is equal to JdV into I plus phi into JdV into U, and F is equal to ZMO into U plus phi into JdV into I. Okay, phi into JdV into I. Now, if it is Kc square this one, so this is nothing but a T square by JdV into ZMO, and this is nothing but a phi is nothing but a, so it is phi into JdV, phi square JdV square divided by JdV ZMO. So, it is nothing but a square will be cancelled. So, it is phi square by ZMO. Sorry, phi square into JdV, because square is cancelled, phi square into JdV by ZMO. So, what is the relations between the ZMS and ZMO? So, I said ZMS is nothing but a 1 minus Kc square into ZMO. Okay. So, now Kc square is nothing but a phi square JdV. So, it is 1 minus phi square JdV divided by ZMO into ZMO. So, it is nothing but a ZMO minus phi square JdV. Okay. So, this playing of the relations mathematics we can do it later on also. Now, if it is this, if this is the equation, this is your equation, this is the equation number 1 and this is equation number again 2, then can you draw the equivalent electrical circuits? What is equivalent electrical circuits? Now, if it is V, let us try to draw it from that equation. So, I have an electrical side where I have an applied voltage is V. So, there is a impedance which is ZdV, the current is I flowing. Okay. Let us ZdV into, let us there is another, so ZdV, if ZdV into I, and now this side I have an mechanical force and I have an impedance ZMO, okay, and current particle velocity U is flowing. Okay. So, what is transduction coefficient? Transduction is phi into ZdV, phi into ZdV U. So, here another impedance phi into ZdB U, ZdB, phi into ZdB will be multiplied, so it is V is equal to ZdB into I plus phi into ZdB into I. So, I have to negate that thing. So, I have a negative impedance phi into ZdB. If I complete these circuits, these two equations stand. B is equal to ZdB into I plus phi into ZdB into I minus phi into ZdB into I and U into minus, sorry, this will be minus and I put it plus. So, this will be, so if I write V, what I writing? V is equal to ZdB into I minus phi into ZdB I plus phi into ZdB I plus U is be there phi into ZdB U. So, this cancel, I got the equation ZdB into I plus phi into ZdB U. Similarly, if you look at the force, F is nothing but a ZMO into I plus, so I have to put another impedance here which is minus phi ZdB. So, minus phi ZdB into U plus phi ZdB into U plus phi ZdB into I. I current will be flowing in here. So, I can write this cancel ZMO into I plus phi ZdB, phi into ZdB, ZMO into U, sorry, ZMO into U plus phi into ZdB I. So, that is stand. So, the equivalent electrical circuits, let us I draw in cleanly, it will be V, there will be a ZdB, there will be a negative impedance minus phi ZdB, then there will be a here minus phi ZdB, ZMO and terminal here I put an impedance phi ZdB, then I apply a voltage here V, current I will be flowing and I apply a force here F, particle velocity U will be flowing. Equivalent electrical circuits. Now, can I reduce it? So, mechanical reciprocal transducer equivalent electrical circuit is this. Now, I cannot realize phi minus phi in negative resistance. Can I realize it? Negative resistance? I cannot. So, how do I realize this negative part in form of coupling coefficient? So, let us I say I put a voltage transformer here. I put a voltage transformer here, a transformer here, whose has a turns ratio is 1:5. Okay. So, if I apply a V voltage in here, it will induce phi into V voltage in here, because turns ratio is 1:5. Is okay? And if a current U is flowing in here, it is induced phi into U current in here. Okay. Now, the voltage V, let us I put a impedance here which is ZdB. So, voltage V is nothing but a, if current I is flowing here, so ZdB into I plus JdB into phi u, which is stand by first equation. Done. Next, this side come. So, this side here I induced, here is the current I have taken, and this side I taken the phi V voltage. So, phi V voltage will be induced in here, that point phi V will be there. Now, if I apply a force in here and a resistance which is ZMS in here and U is flowing, then can I derive the F equation? Then I can say the force F is nothing but a ZMS into U plus ZMS into U plus phi into V, phi into V. Okay. Now, what is ZMS and ZMO relationship, and what is phi and V relationship? I can find out. So, I can say then it is nothing but a ZMS into U plus phi into what is V? JdB into I plus phi JdB into U. I put the voltage V there. Now, once I put the V here, then what I get? I get ZMS into U plus phi JdB I plus phi square JdB U. So, I can write down phi JdB I plus U into ZMS plus phi square JdB. Okay, phi square JdB. So, from there, from the relationship between the ZMS and JdB, if you will find this is nothing but a ZMO. So, if you see these slides, I have derived that phi into, so this is nothing but a phi square phi square JdB 1 minus kc square ZMO into U plus phi square JdB I have taken, and then so ZMS is nothing but a 1 minus kc square ZMO into U. I put the ZMS value, and then if you see this will be cancelled, it is nothing but a ZMO U. So, if I put the ZMS value in here, ZMS is nothing but a ZMS is equal to ZMO minus phi square JdB. So, if I put the ZMS value, it will only ZMO will be stand. So, it is nothing but a ZMO. So, I can write phi JdB into I plus U ZMO. So, this is the electrical, this is the F equation, F stand. So, this is the electrical equivalent circuits for my first circuits. Okay. So, further I can say this phi is a ratio. So, I can say this circuit can be simply transduction ratio if I divided by. So, it is simply I can say that apply the voltage V, and if I say this is a JdB resistance electrical side, and this phi V is induced. So, I can say let us the voltage is reduced by this mechanical force is reduced by phi. Okay. So, it is nothing but a this ZMS will be nothing but a this impedance will be ZMS by phi square, and the current will be U into phi. So, that can be an equivalent circuit. Okay. So, this is the equivalent circuit for a reciprocal transducer. So, when I say that reciprocal transducer, I can derive its equivalent circuits like this way. Okay. Okay. So, next class I will discuss about the anti-reciprocal transducer. Okay. Okay.